Hello, let's understand how ACKs work in Redis. So a Redis master sends down some commands to replicas, which are the set and del commands, basically the write commands, WRITE, write commands to replicas. And the replicas process these commands silently with no response. They do not respond back to the master. The repl-conf get ACK command is a special command. When the master sends this command to the replica responds back in this format. This offset right here, this offset is basically equal to the number of bytes that the master has sent down to the replica previously, and it's just returning back the number of bytes that have been sent down to the replica from the master. The master needs to calculate if the replica with this offset is up to date with the data or not. So the master needs to keep track of how many bytes are actually sent down to the replicas, and the replica just responds with how many it has received and how many it has processed. Alright, so let's say the master has sent down 10 bytes worth of commands down to replicas, and this replica has processed only 5 bytes worth as of now. So the 5 bytes are still left in the input or output stream, right? So it will respond back with 5. The master sees, oh, I sent down 10 bytes, but it has only processed 5, so it is not caught up yet. So that's how we calculate if a slave is caught up. And if it had returned with a 10, then master would have been like, oh, this replica is caught up. I can keep track of this replica as a node that is caught up, that its data is in sync with me. So that's the get ACK mechanism. Master periodically requests ACKs to check if replica is in sync. Replica responds with bytes processed, and that's the offset. See offset tracking example. I'll show you one. So let's say the get ACK is 37 bytes. So after the handshake, we set the offset to be 0. The get ACK command will respond with an ACK equal to 0. But since it was worth 37 bytes, we'll increase the new offset to be 37. It will then let's say the master pings it, the ping command is 14 bytes and we do not get any response. The slave doesn't respond back to a ping command, right? We just increase the offset in at the slave node. After that, the master sends down a get ACK command to the slave. The new ACK that the slave returns will be 51 from here, the 51 that was calculated after the previous command. And since the get ACK was worth 37 bytes, we'll have to increment the offset of the slave to be 88. And this increment needs to happen after the response to the get ACK command. We'll respond with ACK 51 and then we'll increment it to 88. So similarly, set command we do not respond back, but it's worth 29 bytes, so we increment the new offset. And after the get ACK, another get ACK command, the slave will respond back with ACK 117. That tells the master that this slave node has processed 117 bytes of commands. And since get ACK was 37, the new offset will be set to 154. So when the master receives that this 117, it can check if in total 117 bytes worth of command were sent down. And if 117 were sent down and 117 was received back, that indicates to the master that this slave node is then caught up. So let's implement this whole process in the coming video. Hello. We are very close to finishing the replication stage of Build Your Own Redis challenge, and we only have ACKs and wait to implement now. We'll add the support for ACKs and the first stage for wait with no replicas in this video. So let's understand what ACKs are. So if you remember, in my connection pool, no, it was in my Redis config, I have something known as a master REPL offset. These offsets are used to determine whether my master node and my slave nodes are in sync with each other. If they are in sync, then the offsets that they have will be equivalent. All right. And when a master sends a repl get ack command to my slave nodes, it returns back the offset that it has. And with that, the master is able to determine whether the slave node is in sync with it or not. If the offset returned for this command repl get ack is not the same, that we can calculate how many commands are yet to be trickled down to that node. All right. So the command looks like the command that the master sends to the slave looks like this: repl get ack asterisk. Now, an important thing to note is that they are sending an asterisk with the get ack, and we were using asterisk as a delimiter because every command serialized in the RESP serialization protocol started with a asterisk, because an array starts with an asterisk and the last element of this array is also an asterisk. So we'll need to add special consideration to the fact that the last element of this command is an asterisk. So we'll see that how that looks like. So the commands, as you can see, the command starts with an asterisk and it has an asterisk of its own. So if you were using asterisk as a delimiter, only this much of my command will have been considered. Alright, and we'll have these three characters in my buffer remaining. So we'll have to read these extra characters and finish up this command. Alright, so that's something we'll need to add to our RESP serializer. And let's just read what they have given us. Unlike regular commands, when a master forwards a command to a replica via replication connection, the replica doesn't respond to each command. But the repl get ack is a special command and the replica responds. Since the master doesn't receive a response, for each command, it needs another way to keep track of whether a replica is in sync. That's what ACKs are for. ACK is short for acknowledgement. Redis masters periodically ask replicas to send ACKs. Each ACK contains an offset, which is the number of bytes processed by the replica that are sent down by the master. We learn about how this offset is calculated in later stage. Let me tell you how it is. It's just the total number of bytes that have been sent down from the master to the slave. We have a connection right from the master in my slave TCP server. We have this a master socket and we have an input stream for this socket. So the number of bytes that follow this after this handle psync, number of bytes in the input stream coming down from the master after this point, if they are read and the command is processed, we can add the number of bytes processed to the offset. That's just how the offset is calculated. It's just the total number of bytes. That's it. All right. Nothing else. The repl get ack command. When a master requires an ACK from a replica, it sends this command. This is sent over the replication connection that was established during the handshake. When the replica receives the command, it responds back with the repl ACK and the offset that it has. Right. The offset is the number of bytes of command processed. It starts with 0, which is why we set the default value to be 0. In my constructor, where is my constructor? Redis config. I do not have a where is my Redis config? Yeah, see the getter. If the rebel offset is null, we are returning 0. Otherwise, we're returning whatever the value is. So the default value returned from this class, this config class, will be 0 for the rebel offset. In this stage, you'll implement support for receiving attack command and responding with repl ack 0. You can hardcode the offset 0 for now, but we won't because we already have that. Alright, the exact command received by the replica will look something like this. So in my TCP server, I already have switch case for handling all the commands, right? But right now we are only handling the set command. We just need to add support for repl_conf as well. All right, repl_conf, and yeah. Instead of, let me remove these logs. These were for debugging purposes, but it's working fine now. We can uncomment this because we want the commands to be propagated down to the slave nodes. The repl_conf command is not propagated down, only write commands are. All right. And instead of set, we can call the repl_conf method. All right. In my repl_conf method, instead of using the command handler repl_conf, see, yeah, we can add it there as well. If command of one, yeah. So after my repl_conf, the other thing that can follow this is get ack, right? I'm not 100% sure if this will be all in caps. So let me just print that. If it's not in all caps, then we'll have to change it to get ack small. So we'll see that soon. And when we get this get ack command, we know what we have to do, right? We have to return a repl_conf ack followed by uh, the offset that we have, right? So instead of returning an OK, I can string result, and I can call it okay. I let me create string array repl_conf ack. All right. So the first element of this is going to be repl_conf. The second is ack, and then we have my redis config dot get master. Why do I not get redis config dot get master repl offset? But we need to typecast it to string. Yeah. And now we recently, I think we did resp serializer dot resp array, yeah, repl_conf ack, and we can return this instead of this. Okay. But as I said, we need to add a special consideration for the asterisk that is being sent here. So we'll do that. And that is being handled right here, right? Yeah, in this while loop. We'll need to update this while loop to handle that. Okay, so let's see. My command result is this. So this command result, this command array will have repl_conf and get ack, right? Since we are using a star as a delimiter, we'll need to read the extra bytes remaining. But the get ack here will work because we'll have this already in my command area, and I can show that to you as well. Let me print it. this will see the command as well. But now I'm saying that some extra bytes will be left in my input stream. So what we can do is, if my command of 0 is equals command array of 0 is equals to repl conf and command array of 1 is equals to uh, get ACK, then we know we have extra bytes remaining in my input stream. And whatever those bytes are, we need to add them to the offset as well. So see, we are incrementing the offset for each byte that we read, and we'll have to increment the offset for these extra bytes as well, because these are being processed by my slave. My slave is just ignoring them because they're not required for REPL conf get ACK. We just need REPL conf get ACK. We don't need the star to do anything in this challenge. So my command result will be equal to this resp array which will have been returned. And if this is the case, then we need to write it to the output stream as well, right? Because REPL conf get ACK is the only command that returns something to its master. So we need to write to master as well. So now that we have written to the master, we can increment the offset. Why? Because uh, this where is it? This while loop will only have been broken when uh, we would have encountered a star. So we need to account for that star as well, which is being read, but it's not. But it was not incremented here. You see, as soon as we encounter a star, we break, but we're not incrementing an offset. So let me increment that offset for each new command, because my offset is starting from 1 initially. So we are assuming that the asterisk was left behind, was not accounted for the previous command. So when we start processing the next command, we need to account for it. So that's why we are incrementing the offset here. And now let me create a list of bytes that will be in the input stream. Let's just call it leftover bytes. My new array list, and while true, we need to do basically the same thing that we're doing up here, right? So I'll check if my input stream has something left. If input stream dot available, if it's less than equal to 0, then we can break. Then my input stream doesn't have anything that's left to be read. But if it's not less than equal to 0, then we have something in the input stream that needs to be read out. Input stream dot read, we'll just read 1 byte, and it's the data type is int, so we need to typecast it to byte, and we can add it to the leftover bytes. And if int of b is equal to int of this character asterisk, if we encountered another asterisk, we can break, because after this asterisk we have two characters, but we'll do an offset plus equal to 2 for that manually. All right. So if as soon as we encounter another asterisk, you see, my processing will have stopped here, and we need to read these out of the input stream. And if any new command follows this, that will be starting with an asterisk. So as soon as we see, as soon as we encounter an asterisk, we can break out of it. We're safe to break out of it. And if we did not and we read a command, we can increment the offset, and we can convert the bytes that we read to a string to see what we got. We can add it to my string builder, but the byte needs to be typecasted to character. All right. Now, this needs to be converted to hexadecimal as well. There's some uh, encoding issue, and I faced that when preparing for this video, preparing my script for this video, and the solution to that is just this. And with this, we can even print my string builder to see what we got. Let me do that. Let me change the character here so that we know. South leftover SB. All right. And after all the processing, we have calculated the offset, but it's not being stored anywhere. So I need to store it in my Redis config. I can set the master offset to be offset plus the existing offset. Get triple master offset. Yeah. And you see, we are doing this right. Uh, we are doing this if case, and this if assumes that the command array is at least 2 characters long. So if it's not 2 characters long, we do not want to go in here. So we can command array dot length is greater than equal to 2, and just adding something so that we don't get out of bound method. And there is a typo up here. Uh, where is it? Yeah, completed. Let's fix this typo. Do I have an error here? This is line 200. What does double expect? It expects the client as well. Why? Okay, so we need to pass down the client as well. Do I have the star socket connection here? Yeah, master. Okay, so we cannot. I do not have the mass client object here. We're simply passing down the master. Let me make a client object for it. Client master client, new client, and it takes a socket. That's all I want to pass to it. Master dot get input stream and master dot get output stream. What's the issue? Input and output and an ID as well. So the ID for the master can be -1. and instead of master I can pass down client master, and now it should work. So let's see if you're good. Let me commit and push. My code built successfully. Something is wrong. Let's see what is. So the get ACK is all in caps. The command was repl get ACK. That is fine. And as you can see, we received an empty /r/n. So a new line is being printed for it. So we can remove that. So logs are clearer. See, in between these characters, I only have new lines, right? In the logs. That means it's just the empty new line characters. You can remove this. And this is equal to right here. We have the entire string. Repl get hack null command here. You can remove this. And my handle command handler repl conf. Be printing here it's get ack. This is the get ack. Let me see. So what is the issue here? So let's print the result that we got from. We have this command result, right? Let's print that. Because the issue is no content received. The master did not receive any content. It should have. And where am I printing this? I'm printing it here. I think it's in parse. Right here. Yeah. So right here, what did we print? We print the length and then the command that we got. You can remove this. Let's print it inside the if so we know the condition is working fine as well. And right before writing to the master. Let's do another build and see if it's working fine. It's running the test cases. Need to remove this as well. So the logs say that my command result is empty. Why is that the case? Slave TCP server, the command result is empty. That should not be. Ah, that is the issue. RippleConf returns something, but we were not catching it. So the test cases are working now, and we should have passed the test. Alright, as you can see, we passed the stage. And it should also work for ACKs with no commands. With commands, sorry, because we are actually calculating the offset and storing it in my Redis config as well. So let's see if it works. I just need to click here and it will start running the tests for the next stage as well. They're running the tests. We'll see when it's done. Alright, so the test passed as expected. So we can get to the next stage. Let me check one thing. So we're calling the handle command method from master, and in here I'm calling command handler dot set, and the result being returned, we're not returning anything. And so before writing back to the master, let me check once if the string is null or empty. Because if it's null, we don't want to write back anything. If command result dot equals an empty string, I think there are built-in methods, but I don't remember them. If it's not, and command result is not equal to null, only in this case should we write back to the master. Alright, seems fine. And now everything seems fine. Set. Yeah, everything's cool. We can get to the next stage. So let's see what's required of us. You can find notes on how the tester works below. Okay, so I'll explain it to you. The Redis client will, the tester will execute a program like this. The Redis client will then connect to your master and send a wait command. It will expect to receive a 0 back immediately since no replicas are connected. You can hard code 0 as the response. So right now you don't need to understand what the wait command is. You can hard code the response. So we'll do just that. Alright. They'll run a program like this. So that means my program will be started as a master. So we need to add support for this wait case in my master TCP server. I can just copy this and make it wait. And right now, all we need to return, it will expect to receive a 0 immediately. It's just returning a number and nothing else. But is it in a RESP format? It will be a RESP integer. Okay. Wait command Redis. The command blocks the current client until all previous write commands are successfully transferred and acknowledged by at least the number of replicas you specify. So that's what the wait command does. It stops my master from receiving any commands, from reading any commands for this many milliseconds. It waits and or it waits either for this long or till this many slaves are caught up with it. So that's what wait command does. I'll explain it to you better in the next video. What we can do right now is simply return this 0 as a resp integer. The format it returns is always, yeah, as you can see, it returns an integer. So what we need to return back is an integer as well. So here my response can be, I don't think I have a integer here, right? Let me see. Resp serializer. Okay, yeah, no, we don't. So we need to add public string resp integer. It takes an int I and converts it to the resp integer format. Let's see what the resp integer format is. Yeah, it will be better here, I think. So simple strings, integers. So an integer starts with a colon. Yeah, integer starts with a colon, an optional plus or minus as the sign, or one or more decimal digits as the integers is unsigned, base 10 value, and a CRLF terminator. We do not need to encode the length. It's just colon plus the integer followed by a slash r slash n. So that's what we need to do here. Alright. String builder SB is equals to new string builder. We need to append a colon like so. Then we need to append the integer. Then we need to append slash r slash n, and we can return sb.toString. Alright, and in here all we need to do is resp serializer dot resp integer, and they are telling us to hard code 0, but we know what this is, right? This is the number of slaves that are caught up with it. So if we need to maintain a number of slaves that are caught up with my master, we should create a variable somewhere that keeps track of it. And where are my slaves stored? In my connection pool. So if my slaves are here, I should also maintain a number that represents how many slaves are caught up with my master. So I'll create a variable and I'll call it slaves that are caught up is equal to 0. And you see, how do we determine if a slave is caught up? It's determined based on the get ACK which we just added the support for. We'll send a get ACK command to the slave and it will respond back with the offset that it has. The offset is just the number of bytes that have been processed by it. So we need to compare the bytes that were sent down by the master and the bytes that have been processed by the slave. So we have the bytes that are processed by the slave as response to the repl get ack command, but we also need to store the number of bytes that are sent down to the slaves. All right. So we'll create another variable and we'll call it bytes sent to slaves, and I initialize it with a 0. And what I mean to tell you is that if we public void slave ack, and it will have int ack response. What I mean to tell you is we'll get a response from a slave, which will be in response to the repl conf get ack star command, and whatever the response we receive back from the slave, we'll send to this method. And in this method, I can compare if this dot bytes sent to slave is equal to ack response. That means the slave for who the variable is, whatever the slave sent back this response, that slave is now caught up with my master. So I can increase this count now. All right, I'll explain it to you better in the next video. For right now, we are just hard coding this result anyways. So my connection pool dot slaves that are caught up. All right, this will be the number of slaves that are caught up, and initially it will be 0. And since we are not processing the response of the repl get ack command, see, repl get ack response with repl ack. We have this command handler for repl. In here, we need to add a case for ack as well. All right, we'll add that soon. So yeah, that will look something like this, and it will be ack and command of 2 will be equal to the ack response. And with this ack response, we can call connection pool dot slave ack with the ack response. All right, so this is something that we'll be doing. Let me explain it to you a little better. So when my slave receives this command get ack, it will return the offset that it has, the bytes that it has processed. In this format, it will be returned back to the master. So master will receive a repl ack command. So the repl command will come here, and for the ack command, we'll get the offset that the slave had, and that will be equal to the ack response. For the ack case, that will be equal to the ack response, and we need to process this ack response, right? We haven't added any support for processing this ack response right now, but we need to calculate how many slaves are caught up. So right now we are hard coding the result to be 0. In the next stages, we actually need to calculate how many slaves are caught up. As you can see, the default value is 0, and that's what we are returning, and that's what is required of us right now. We need to return back a 0. But in case the number of slaves that are caught up is not 0, we need to calculate the slaves that are caught up, and that will be done right here. So with this, we will pass this case and this stage, current stage, and that should be enough for this. So let me commit and push and test. You see, our tests are passing. All right. So that's it for this video, and I'll see you in the next one. What we'll do in the next one is actually work on the wait command. In this stage, we were just hard coding this result. In the next stage, we'll calculate how many slaves are caught up, and we'll wait for at least 3 slaves to be caught up, or for 500 milliseconds, or at least 7 slaves to be caught up, or 500. Okay, so we'll add support for this, and I'll see you in the next one.